In this video, we're going to be converting between component form, linear form, and trig form of different vectors. So let's say that we have a vector that is 3, 6, and we want to find the linear form. We know that when we have a vector like this means we have it in the form a, b, where a is going to be the coefficient of I, and b is going to be the coefficient of j. So this is equal to 3i plus 6j. So that's going to be our answer. Now let's say that we have the linear form, 4i plus 9j, and we want to find the component form. So we know that in linear form, this is ai plus bj. So we can see quite clearly that we have 4, 9. Now, let's say we want to convert our vector 4i into component form. So we can see that we just have a 0j. So this would just be 4, 0. So 4i means that we have 4 units in the x direction, and then we have 0 units in the y direction. So this is the same thing as plotting the point 4, 0. Or not the point, because this is a vector. And that would be on 4. Now let's say we have the vector 25, negative root 3 over 2, negative 1/2. And we want to find the trig form. So we know that in trig form, we would have r cosine theta, I plus sine theta, j. So we want to match that to this. So first we have to identify what r is. So here, we see the magnitude is going to be the number outside the vector, which is going to be 25. So we also have to find cosine theta and sine theta. So from this, we can see that we have cosine theta here, and we have sine theta here. So we need to find an angle where we have a negative cosine and a negative sine. So that's when we're in quadrant 3. We have a negative x and a negative y. So then this is going to be our reference angle for when we have root 3 over 2, 1/2. And that's when we have 30 degrees. So we know that this is going to be 30 degrees plus 180 in Q3. So that's going to be 210 degrees. So this is 210. Now we can write the trig form, where we substitute in theta is going to be 210, and also our r. So we're going to have 25 cosine 210 I plus sine 210 j. So that's the vector. Now let's say that we have a vector 3 over 4i plus 3 over 4j, and we want to find the trig form. So that means that we want the vector in the form r cosine theta, I plus sine theta, j. So we need to find magnitude r and also the angle theta. So that we see from our components, we see that the vector would be 3 over 4, 3 over 4, because that's a and b. So we can see that our x would be 3 over 4, and our y would be 3 over 4. So then we have to find magnitude using r is equal to the magnitude of v. So it's going to be the root of x squared plus y squared. So we're going to have 3 over 4 so this is equal to 9 over 16 that's going to be 18 over 16. And then 18 over 16 is the same thing as 9 over 8. You can take 9 out. So you have 3 over the root of 8. You can split 8 into 2 and 4. And 2 and 4 can be split into 2 and 2. So we can bring a 2 outside. So this would be 3 over the root of 2 times the root of 2. You could also rationalize this. So then you would have just 2 times 2 cancels out. So you see that you can multiply it by. And then you have 3 over the root of 2. Or actually, you can just multiply by root of 2. So then that cancels out. And then you have 4 in your denominator. So your magnitude is going to be this. Now you have to find your angle. Since we know that x is equal to 3 over 4, and that's greater than 0, and we also know y is 3 over 4, and that's greater than 0, they're both positive. So that means our angle has to be in quadrant 1. We have positive x and positive y. So then we have to find the angle using tan theta, which is equal to the ratio of y over x. So here that's 3 over 4 over 3 over 4, which is equal to 1. So that happens when you have an angle that is 45 degrees. For example, when we have root 2 over 2. So that's our angle. So if we want to get our trig form now, we now have r, which was 3 over root of 2 over 4. And then we have cosine 45 degrees I plus sine 45 degrees j. So we have our theta, and we also got our r magnitude. So let's say that we have a vector 9 root 3 over 2 negative 1/2, and we want this to be in component form. So what you would do is you need to distribute that 9. This is component form, so it's going to be the triangle. And then you would have 9 times root over 3 over 2, which is going to be this. And then we have 9 times negative 1 over 2, negative 9 over 2. Now you can write this in linear form. So you would just add I. So that's our linear form. Now, for our next question, let's say that we have a vector that is 12, negative 15. Let's find the magnitude direction form. So what we would do first is we need to find the magnitude for our vector, which is vector AB. That's going to be the root of a squared plus b squared. And that's 12 squared plus negative 15 squared. That's 144 plus 225, which is the root of 369, approximately 19.24. That's our magnitude. So we also have to find our reference angle. So we know tan theta is y over x. That ratio is negative 15 over 12. So negative 15 over 12 will equal to negative 1.25. So that's tan theta, though. We want to get just tangent. So that's tan negative 1 of both sides. our theta would be equal to tan negative 1 of negative 15 over 12. So we can actually just take the tan negative 1 of 15 over 12, removing that negative. So this would be equal to your reference angle. And this would be 51.34 degrees. So now that we have our reference angle, we need to know the exact quadrant that it's in, because our reference angle would only be in quadrant 1. So because we have 12, negative 15, we have a positive x and a negative y. So when do we have a positive x and a negative y? So that's going to be when we're in Q4. So when we have an angle in Q4, this means that we would have 360 degrees minus our reference angle. So this would be equal to 360 minus 51.34, and that's going to be equal to 308.66 degrees. So that means that for our magnitude direction form, this is going to be a magnitude of 19.24 and a direction of 308.66. So for our next question, let's say that we have a vector that is negative 2 root 3, 2, and we want to get the trig form. So that means that that's r cosine theta I plus sine theta j. So we need to find the magnitude r and the angle. So let's find our components. Here, that's your x component, your y. So what you do is get your r magnitude. So we can get x squared plus y squared, which is going to be the root of negative 2 root 3 squared plus 2 squared. This is going to cancel out that root, and then we would multiply negative 2 times negative 2. That would be 4 times 3 plus 4. And this is going to be the root of 12 plus 4, which is the root of 16, which is 4. So that's your magnitude. So we need to find our cosine theta and our sine theta. So cosine theta is equal to x over r on the unit circle, and sine theta is equal to y over r. So if we know what our x is, which was negative 2 root 3, you also know what our r is, which we just found, which is going to be 4. So that's going to be what our cosine theta is, which we can write negative root 3 over 2. And this we can write as 2 over 4, which is 1/2. Now we have to find the angle. And here we know we had a negative cosine and a positive sine. So we need to find the quadrant where we have a negative x and a positive y, which is here, quadrant 2. So we know that this is going to be a reference angle for when we have root 3 over 2, 1/2, which is pi over 6, because we have our cosine theta and our sine theta there. That's our x and our y. But we're just looking, when we say this is our reference angle, that's not looking at that negative sign, so that's y. But now we have to find that actual value where it's in Q2 and has that negative root 3 over 2 and 1/2. So that's going to be when you have 5 pi over 6. So that's here, because this is going to be 30 degrees. So that's your reference angle, and that's 5 pi over 6 equals theta. You could also get this from doing theta minus pi over 6, and pi is equal to 6 pi over 6 minus 5 pi over 6, which would also give you 5 pi, which would also give you pi over 6. or this is just pi over 6, my bad. So then you would get 5 pi over 6 here. Now, if you write your trig form now, this is going to be equal to 4, which was our magnitude. Then we have cosine, and our angle was 5 pi over 6 I plus sine 5 pi over 6 j. So that's your answer. Now, let's say we have another question, 11. Let's say we want, for this vector, we want our component form, which is going to be when you have AI plus BJ, and we want exact values. So we can first see that this is currently in our trig form, because we have the form where we have a vector r cosine theta I plus sine theta j. So here we can see that we have an r magnitude of the root of 13. Theta is going to equal to 180 degrees minus inverse tan of 2 over 3. So we need to understand what this angle means. So let's let alpha equal to tan negative 1, 2 over 3 right here. Now what we're going to do is we can write our reference angle triangle. So let's say that in a triangle, we have an opposite side that is going to be 2, and a hypotenuse that, this is our angle. This would be the opposite side, and then our adjacent side would be 3, because tan is opposite over adjacent. So that means that in order to find the hypotenuse, that would be equal to the root of 2 squared plus 3 squared, and that's going to be the root of 13. This is x squared plus y squared for your hypotenuse. So we know our hypotenuse is the root of 13. Therefore, if we write what cosine of our angle is, that's going to be 3 over the root of 13, and sine is going to be 2 over the root of 13. This is opposite over hypotenuse, and cosine is adjacent over the hypotenuse. Now, if we have find our actual angle, that's going to be 180 degrees minus alpha. That's because we are going to be in quadrant 2, because we have a cosine that is positive, and we have a sine that is also positive. Or actually, this is going to be a negative, because 3 over the root of 13 would be negative. So we are looking for when we have a negative x and a positive y. So this is actually negative 3 over root of 13, and that's 2 over root of 13. So now we can substitute what we have into our vector. So this is going to be equal to the root of 13 times negative 3 over root of 13 I plus 2 over the root of 13 j. So you could multiply through by the root of 13. And then you would get that root of 13 cancels out. Or let's just rewrite the whole thing. So this would give you a vector that is negative 3i plus 2j, because that cancels out, and also this cancels out. So that is your vector in our linear form.